All right, welcome back to the deep dive. Anyone who's wrestled with running Kubernetes knows it can feel like, well, like taming a dragon sometimes. Today, we're diving into a solution that aims to make that dragon much more manageable. Amazon Elastic Kubernetes Service, or EKS. Our mission here is to kind of unravel EKS, give you a shortcut not just to what it is, but really why its design choices matter for, your setup. Okay, let's unpack this.
Yeah, and what's really fascinating here, especially if you've run Kube before, is how EKS just shifts that whole operational side of things. AWS takes on the entire burden of the Kubernetes control plane.
The whole thing.
The whole thing. And that's not just like a nice to have. It means AWS is managing the API servers, the scheduler, controllers, and crucially, et cetera.
Et cetera. The brain.
Exactly. The cluster brain holds all the state, all the config. AWS makes sure it's highly available, secure, spread across multiple AZs, which for you really means fewer sleepless nights worrying about master nodes going down.
Okay, so it's more than just managed. It's actually taking away some of the really critical, often painful infrastructure bits. That's huge for getting stuff done faster. So, given that AWS handles that control plane, what does an EKS cluster actually look like from, our side, beyond that invisible part?
Right. So while the control plane does its magic, where you interact and where your costs mostly come from is the worker nodes. And here's where you've got some really key choices to make. These worker nodes, where your apps actually run. Well, they can be standard EC2 instances.
Okay, the usual suspect.
The usual suspects gives you total control. Maybe you need specific hardware like GPUs, or you want to really fine-tune costs. Or for something a bit more streamlined, you can use AWS managed node groups. They make scaling and updating those EC2 instances quite a bit easier.
And then there's Fargate. Everyone talks about Fargate for simplicity, right?
Precisely. Yeah, for the ultimate simplicity, you just deploy your apps straight onto serverless Fargate. And it's important to be clear here, Fargate isn't really a worker node type like EC2. It's more of a compute engine that runs your Kubernetes pods. But you never see or manage the underlying servers. AWS handles all that. But you still deploy your apps the standard Kubernetes way. Kubectl, YAML, manifest those blueprints, telling Kube what you want. The EKS control plane then figures out how to schedule your pods onto those EC2 nodes or onto Fargate.
Gotcha. That Fargate distinction is really key. It almost sounds like a different kind of ops challenge, maybe less server patching, more focusing on pod resource requests to manage cost.
That's a fair way to put it, yeah. Cost optimization looks a bit different.
So beyond the control plane and the workers, what else makes up a sort of full EKS picture? What else is critical?
Oh yeah, a proper EKS setup definitely relies on a few other pieces. Networking, for instance. You'll typically use the AWS VPC CNI plugin that gives your pods actual VPC IP addresses. Makes network integration, security rules much simpler.
Integrates tightly.
Exactly. Then there's storage. EBS, EFS, maybe S3. How you attach that persistently inside Kubernetes often uses CSI drivers, container storage interface drivers.
Okay.
And you absolutely need observability, logging, metrics, tracing. Critical for any distributed system like this. These aren't just optional extras. They're really integral for production.
Okay, so pulling this all together, what does this mean for you listening if you're thinking about jumping into EKS, maybe coming from self-managed Kubernetes or even another container service?
Well, connecting it all up, that first big decision point for you is really going to be Fargate versus EC2 for where your apps run.
The compute layer.
Compute layer. Fargate gives you that amazing operational simplicity, great for starting out or if your workload jumps around a lot. But yeah, cost optimization might mean really nailing those pod resource requests. EC2, especially with managed node groups, offers more control. Better for, say, long-running predictable workloads or if you need specific hardware.
Makes sense.
And remember, cost-wise, there's a small hourly charge for the EKS control plane itself, plus whatever you pay for the EC2 or Fargate resources underneath.
Right. Got to factor that in.
And security, definitely need to talk about IRSA. IAM roles for service accounts.
Okay, IRSA. Why is that so important?
It's non-negotiable, really. It lets you tie AWS IAM permissions directly to your Kubernetes service accounts, pod by pod. It's much more granular and secure than giving permissions to the whole node. Think multi-tenant clusters IRSA makes them way safer and easier to audit.
Much tighter control.
Exactly. So my final recommendation, start small, spin up a little EKS cluster, maybe use Fargate or a managed node group. Deploy something simple, like an NGINX web server. Just get your hands dirty with Kubectl and feel how it operates.
That's really practical advice. It ties back nicely to that initial promise, right?
Hmm.
EKS mixing Kubernetes flexibility with AWS scale and reliability, but also showing where your focus needs to shift operationally. It really does seem
Yeah.
like a powerful platform for modern apps.
Definitely. And it raises an interesting question for you to think about. How does using a managed service like EKS, which abstracts away so much core infrastructure, change your view on what's truly cloud native? What new things does that let you innovate on when you're not managing, etc.? I really encourage you dig into the AWS docs a bit. Maybe try spinning up that simple Fargate cluster, see how it feels firsthand.